Hello there. My name is Johnson, and I'm introducing Retina AI, which is an automated eye disease detection system. Well, Retina AI is a deep learning system that analyzes retinal images to automatically detect eye diseases like diabetic retinopathy and glaucoma, which are meant for like blindness. So it simply allows to detect these diseases, and its goal is to provide a fast, accurate, and screening tool that can assist nurses, clinicians, and all the people who take care of our eyes expand access to timely eye care. By doing this, they're allowing the system to easily detect eye defections and provide diagnosis by the what by the clinicians. So these clinicians will be able to like fast access the data of the eye disease, then they'll be able to diagnose. So provide that simplicity and fast effectiveness. Yeah. So this is the project overview and core question. Well, the project purpose is to automate diagnosis of eye diseases from retinal images using deep learning. So simply, that's our objective. And the central question is, does this AI model truly think? We shall see that in the next stage. So this diagram that is here is just shows the project flow where we have the inputs whereby the patient data or the picture is fed into the system, the disease picture. Then the process whereby our cutting edge AI called Retina AI analyzes the data, then it outputs the information by delivering the diagnosis. Like let me say it will tell you this eye defect is now retinopathy or it is glaucoma, among others, right? Yeah. So the question is now, can computers think? This is the question we want to answer. Well, this Retina AI that we have is under the weak AI perspective, whereby our Retina AI exemplifies the John Searles concept of weak AI, right? So it allows simulation, though it doesn't genuinely think, but it processes pixels without understanding what a retina is or the impact of blindness, right? Yeah, so it's learning and memorization. It allows it actually doesn't work like humans do, but it's essentially sophisticated lookup to the table that memorize statistical patterns from various images. So we fill it with images, allowing it to memorize. So it learns by memorizing. So we feed this and give it a different data set, let me say, of images that based on certain disease defects, like let me say retinopathy or glaucoma, and all it does is to analyze and give you learn among them. So as it continuously learns, it will know which one is which with time and all that. Yeah, so the Chinese room argument, well, Searle's famous thought experiment applies directly to our retina AI, like a person in a room following these rules to process symbols they don't understand, right? Yeah, so the network weighs it weighs and biases a book of rules. Well, this can be specific versions of a Turing test, right? So this AI simply manipulates symbols, yeah, without understanding their meaning. So it lacks true comprehension of what it's analyzing. So we just feed it with symbols and it analyzes them. Yeah, so this is the limited intelligence spectrum of our Retina AI, whereby it has a narrow slice of human intelligence types, whereby you have the logical mathematical method, whereby here process patterns and it processes patterns and applies algorithms effectively. We have the visual spatial. This one recognizes shapes and features in the images of those shapes. We have the linguistic. This one cannot communicate with patients or understand verbal history. Well, this one is absent. We do not have it there, but it is meant for like let me say the different languages. Let me say that will be inserted by the patient's feed. So we have interpersonal, whereby these ones are also cannot emphasize with patients or understand emotional context. So interpersonal and linguistic are negated from this. Yeah, we mostly deal with the visual spatial and the logical method. Yeah. So could computers ever think? So in this strong AI position, with sufficient complexity, mind could emerge from computation, right? So if you have high complexity, the mind could emerge from computation. That is how complexity aspect works here. Yeah, the computation itself would easily affect the what? It would easily affect a complex system. Well, in another way, when we say human brain is essentially a biological computer, well, from this, we realize that the brain is a biological computer because we think with our brains and we reason with our brains. Then, well, a digital replica could achieve the same cognitive functions. Let me say we have a replica of our brains. Yeah, we know very well that these brains think, and if I replicated a system that thinks exactly how I do, that means I would have the same functionalities and enable me to get the same results from that system. The philosophical changes involve the syntax versus semantics. Okay, then we have more complexity, which is not equal to the understanding, of course. Then we have more trillion node networks, which may just elaborate symbol manipulators. Like, let me say we've connected so many nodes, and we just want them to diagonalize like different symbols of eyes, and they differentiate each eye defect separately. So the frame problem of Retina AI, if we are to narrow it down, we start from Retina AI's narrow frame. This one analyzes images for specific diseases within a defined context. We have diseases, so its job is to analyze specific diseases, right, that affect blindness. Then, when we come to the human clinician's broad frame, this one considers the patient's history, environment, genetics, and emotional state. Yeah. Then we have the challenge whereby how can this AI know that information is relevant without being explicitly programmed, right? So that's the challenge that we shall face. But to find out how this AI can actually what know this information without being programmed. So in this way, a truly thinking AI would need to solve the problem, showing an ability to reason about the context without explicit programming for this every scenario. And that is our frame problem that we are looking at. Yeah. So the mathematical mind versus human intelligence. Here we have superhuman capabilities and human only capabilities. So under superhuman capabilities, our retina AI may outperform humans in such ways. We may have speed of diagnosis, so we can provide quick diagnosis. We can consistently analyze. Then we can also provide a lot of pattern recognition whereby it will differentiate different patterns of eye diseases and recognize which one is which. Then it can process also billions of calculations per second. That means it has high processing speed for different eye defects. Then if we are to look at the human only capabilities, that means these are only humans, but our AI may not be able to do this. So it can form a hypothesis beyond training. It may not be able to do that because this hypothesis may be done by maybe a doctor or something. Then feel compassion for patients. It has no feelings. Apply contextual wisdom. It doesn't apply that. Then appreciate the beauty of what it sees. Doesn't appreciate at all. Right. So our value proposition for this project, perhaps the most profound takeaway is that we don't need machines to think in the human sense to create tools that can significantly benefit humanity, right? And that is very true. We don't need these machines to think in the human sense to create these tools that can significantly benefit us. Otherwise, we just have to think of ways of augmenting, accelerating, and accessing them. So in each way, where there's augmentation, this AI tool is to enhance human capabilities, not replace the human thought. And we also see that we are to acceleration, we are to provide faster diagnosis and screening to address global health challenges. We also, the accessibility, it brings expert level screening to undeserved regions. Yeah, that's how we resolve those issues. Now, our conclusion is the power and AI limits of AI. Yeah, the power and limits of AI. So, our Retina AI project demonstrates both the remarkable potential of weak AI and while it cannot think in human sense, it represents a powerful tool that can transport healthcare delivery. So, we are simply providing a solution that can transform the health sector by uh, improving the different diagnosis procedures that would help solve the doctors or clinicians problems, instead of him coming to have to look into your eye all the time or have to check, especially in those rural areas, and he just bases on what he knows. This AI is there for him. Yeah. So the future lies not in creating machines that think like us, but in developing tools that complement and enhance human intelligence. That's all I had for you. Thank you very much for listening and have a great day.